Every time a local assistant fails, retries, repairs itself, or gets corrected by you, it leaves evidence for future training. Most tools throw that evidence away. They keep diagnostic logs and build reports, but they lose the decision the system should learn. This video is about the missing layer. Fine-tuning does not begin with the model itself. It begins with the examples your tool records while it works. If you build local tools or command line agents, your logs are not just troubleshooting notes. With discipline, those notes become lessons and training events. That is the learning loop we are building here. Logs are evidence, but training examples are different. A log shows what happened after a run. A collection of training examples shows the model which action worked. Logs help you troubleshoot a run, but they are not enough for learning. The model needs the accepted action. It also needs the safety rule behind that action. Most systems stop at the witness layer. Better tools and training systems keep clean examples for the next model. Do not train directly on raw traces. Raw traces are evidence, but a trace is not a training example yet. It may include private paths, prompts, project details, and the text printed in the terminal during that run. Even a successful run can contain bad middle steps. A failed run can still contain one useful clue. Redaction keeps clean records and rejects risky ones. Think of traces as security footage for a local tool. The footage proves that the run happened. Clean examples teach the future model what to do next. Use 3 different records. The first record captures what happened during the run. The second record stores the lesson. The third record becomes the training example. Keep each role separate from the others. The example stores the input, the accepted action, and the result. Then the model can learn which repair worked. The first layer is evidence, and every run creates it. The trace log records what happened. The run ledger records the stage, the attempt, and the outcome. Then the tool writes training examples and evaluation files. Redaction and quality gates decide what is safe to use. After that, model experiments can begin. The deployment gate makes that behavior the default choice for future runs. The witness layer is the record of the run. It stores what the tool tried and what came back. Keep this layer append only and local. Think of it as security camera footage for the workflow. It helps answer what happened when a run goes wrong. It should not pretend to be wise. It should not compress away messy facts. Preserve the evidence for later stages. Layer 2 is memory. This is where the tool turns repeated evidence into memory it can use later. The lesson is smaller than the raw log, but broader than one example. It can say that a stage often fails for the same reason. It can remember that one repair sequence usually works. This gives retrieval and review a useful starting point. The tool can stop rereading every log and start remembering the pattern. Layer 3 is the training example layer. This is where the tool creates a training event. A training event stores the task context, the accepted repair, and the outcome. A normal log says that a command failed. A training event says which repair worked. A log is not a training example by itself. Training events sit between evidence and model training. Transcript repair is a clean example. The verifier compares the intended narration with the spoken result. If they do not match, the tool records a training event. That event stores the intended phrase. It stores what the verifier heard. It stores the repair that passed. The model is not learning to rewrite everything. It is learning a narrow speech repair decision. For a command line agent, a training event should focus on one decision point. Start with the tool states, the available commands, and the attempts that already failed. The output is one next command, plus a short reason. Skip the whole messy run and train on the known decision. Run the clean build before retrying deployment because the artifact is stale, that is narrow, testable, and useful. It is not training a general agent. It is training one reliable next action for a known class of failure. Visual pipelines create examples too. Start with a generated slide plan and the edit that was accepted. The output has a critique category, a suggested fix, and the final plan. This helps a local critic learn repeated preferences. Make the labels larger and use less text. Break one crowded slide into multiple steps. Show the process on screen, not just in narration. Human taste still leads the final decision. The training event captures routine feedback so human attention can move to harder choices. Build repair is a strong first task. The input is the failed stage, the error message, the retry history, and the current artifact. The output is a repair plan, a command sequence, and an expected verification step. The key is the outcome. Did the next build pass, and was the fix accepted? A failed repair can become a negative example with a clear label that turns debugging history into a small repair skill. The model is not guessing in the abstract. It is learning from repairs that were measured. Quality checks protect the training examples. Keep examples only when they are complete and private details are removed. Drop records without a target answer or a known outcome. Ignore short service failures. Reject examples that are too large, incomplete, or missing source file. Then run redaction and save the report. The report is how you prove the examples are safe. Export the training examples into clear files. Use one group to teach the model. Use another group to check development choices. Keep a final group aside for the final test. The manifest records the counts, versions, quality gates, and how those groups were chosen. The redaction report records privacy decisions. These files make the learning loop easy to repeat. Evaluation comes before training. Write the exam before you adjust the model. Start with decision accuracy and valid structured output. Then test meaning preservation and privacy compliance. The test set shows whether the local model learned useful muscle memory or copied noise. If you cannot evaluate the behavior, you are not ready to fine-tune it. Once you have enough clean examples, you can build small local specialists. Start with a narrow model, not a general agent. Keep the larger system in charge. One specialist can choose the next repair step. Another can rewrite narration to avoid known speech mistakes. Another can classify build failures or repair the formatted result. The first useful model is usually boring. It handles repetitive decisions that currently need a cloud model or a human. This is where local models become practical first. The roadmap is simple. Start with retrieval over past runs and stored notes. Add a local base model for narrow, offline decisions. Compare it against a stronger model on a saved evaluation set. Tune a small adapter for one narrow task. Deploy it behind an experimental flag. Keep a fallback to the stronger model or human review. Keep logging the results. That is how a local model earns trust, one measured behavior at a time. Choose one small decision with a clear outcome. Build classification works because the build turns green or stays red. Data shape repair works because the parser accepts the result or rejects it. Transcript repair works when speech recognition confirms the spoken words. Choose a visible pass or fail signal. Do not start with a general agent. Pick a narrow workflow part with frequent examples. Local inference is only the first step. Local memory helps the tool understand each run. Local training examples turn corrections into useful assets. The proof layer checks the behavior before anything changes. Small helper models handle repeated work. Together, these parts make the local tool better over time. The goal is not a giant model that does everything. The goal is a tool that keeps better evidence, learns from repeated decisions, and improves only when the proof layer says it should.